There is a 2-second formula that answers every how many hosts subnetting question on the CCNA exam. 2 to the h minus 2. By the end of this video, you'll know exactly how to use that formula with no calculator, no tricks, and no guessing. Welcome back to the CCNA study series. I'm Colleen with Mom Teaches Tech, and if you've been following along, you already know how to subnet by number of networks. Today, we're going to focus on the flip side and subnet by number of hosts. This is the other half of subnetting, and it's one of the basics that you need to know to pass the 200-301 CCNA exam. So if you missed the previous video, I'll link to it right here. Go watch this first and then come back to this video. If you're just learning to subnet, watch my video series on subnetting from the very beginning. If you're somewhere in the middle of learning to subnet, try to answer the questions that I post. Like right now, I'm going to post a question. Try to answer it. If you can't answer it, then you're in the right spot and you should watch this video in its entirety. Here's our question. A company needs at least 50 usable hosts on each network, starting with the network 192.168.10.0/24. What subnet mask do you use, and how many subnets does that give you? Go ahead, pause the video now, see if you can answer that question. Okay, keep that question in mind. By 10 minutes from now, you'll be able to answer that question and explain why. Now we're going to switch to pen and paper, or, hand and your brain. That's what you've got to use for the CCNA. No calculators, no spreadsheets, no cheat sheets, unless you create your own little sheet, which you can. I show that in another video. Anyway, let's go ahead and solve this problem. So let's talk about what 2 to the h minus 2 actually means, because it sounds like math, and it is, but it's very simple math. H stands for host bits. These are the bits in your subnet mask that represent the host portion. Remember, your IP address and your subnet mask are ANDed together, and this is how you determine the network and host portions of the IPv4 address. So everywhere there's a 0 in the subnet mask, this is your host portion of your network. We're working with zeros when we look at the H here, because H is equivalent to 0 in the subnet mask. And here's why we subtract 2. Every subnet has 2 reserved addresses you can never assign to a device, and we're looking for usable hosts. The network address, that's the first one, and the broadcast address, that's the last one. You cannot use those. So whatever 2 to the h gives you, you subtract those 2, and that's your usable host count. Let's go ahead and make this concrete with our example question. First, we know that we're using the host formula because that's what it's asking for in the question. So over here, where number of hosts goes in the formula, we can write 50 hosts. Now we're looking for our power of 2 that will equal 50, but there isn't one. That's okay. We just need to move up to the next number, which is 64. 2 to the power of 6 equals 64. And we need to subtract 2 for our network ID and broadcast IP address. That equals 62, which is definitely more than 50. So when you are subnetting, it is important to know that you may not be able to subnet to the exact number of hosts that are required. That's okay. You just pick the higher number. All right, now here where we had our H, we replaced it with the number of 6. Remember, we're talking about host bits right now, which are zeros. Previously, we were subnetting by number of networks, and we were moving the ones in the subnet mask to the right. You must keep this straight. In the subnet mask, We are counting the zeros when we're solving for host bits. If we look at our starting subnet mask in binary, it's 8 zeros with a 255.255.255.0. For our new network that will allow for 62 usable hosts, we need 6 zeros, not 8. So we just come from the right here and put in our 6 zeros. Then the rest must be ones because of the contiguous ones rule. That gives us 2 ones in the last octet. When we convert these 8 bits in the last octet to a decimal value, the value is 192. So our subnet mask will be 255.255.255.192. Now all we need to do is lay out our networks by network ID, the broadcast IP address, and our usable IPv4 addresses in between the network ID and the broadcast. This is easy if you use the magic number and block size. We learned about that in the last video. We know that the first network will start with the first IP address from our original IPv4. That is 192.168.10.0. Now we just calculate the rest of the subnet IDs using the block size that we get from the magic number. Our magic number is 256. We subtract the interesting octet of the subnet mask from the magic number. That interesting octet was 192. 256 minus 192 equals 64. Hey, if you're tempted to use a calculator here to do your subtraction, don't do it. You need to do this subtraction by hand. In my class, if a student hasn't subtracted for years, which I mean, who has really, I will usually do it with them. I'll come over to their desk. I'll help them subtract. I do it up in front of the class. I tell my students, use your fingers, toes, and nose if you need to, but don't revert to using a calculator. Don't pull out your phone and open your calculator. Just don't do it. You cannot do that on the CCNA. And if you get in the habit of doing that now, it's just going to be an extra step. That's going to be another layer that you're going to have to get rid of for taking the CCNA exam. So please do your addition and subtraction by hand. Okay, we have our block size. It is 64. We just need to add that to the IP address in the last octet as well, because the last octet was our interesting octet in our subnet mask. So that's our interesting octet in the IPv4 address. 0 plus 64 equals 64. That gives us our next network ID. 64 plus 64 equals 128, which gives us our following network ID, 192.168.10.128. Then our next network ID is 128 plus 64, which equals 192. Then our next network ID, wait, I'm trying to trick you here. We cannot get a decimal number 256, which is what we would add up to if we added 64 here. So what this does tell us is that we've reached the end and we calculated our network IDs correctly, because if you get to 256 at the end, you know that's one way to check and make sure that you've gotten your network IDs calculated correctly. Get to 256, but it's not another network, right? It's not another network. Let's make this look official. Let's fill in the first part of all of these IPv4 addresses. We'll do a little time lapse. Now we can just go backwards and fill in our broadcast IPv4 addresses by subtracting 1 from our network IDs. Conveniently, we wrote out 256 up here. We can just subtract 1 from 256 and we end up with 255. The fourth network has a broadcast IP of 192.168.10.255. Looking here at the third network, we can subtract 1 from the network ID in the fourth network, and we get the broadcast IP for our third network, which is 191. Now we need the broadcast IP for the second and the first network. Quick little time lapse here for those. Okay, hopefully you're getting this pattern down. Now, for the first and last usable hosts, we just add one to our network ID and we subtract one from our broadcast IPv4 addresses. Looking at network 1, we add one to the network ID. We end up with 192.168.10.1. We subtract one from our broadcast. We get 62. Our last usable IP address for this first network is 192.168.10.62. Okay, you do the rest. I'm going to put this on a little time lapse again, and we can meet after the time lapse is done and see if you got all of your first and last usable IP addresses correctly, and then we'll answer that question. Here we have all the information we need to answer our question from the beginning of the video. A company needs at least 50 usable hosts on each subnet, starting with the network 192.168.10.0/24. What subnet mask do you use, and how many subnets does that give you? What subnet mask do you use? Well, we calculated this using our zeros. We know we needed 6 zeros. That left us with 2 ones in the fourth octet. So our subnet mask was 255.255.255.192. If you were asked to answer this in slash notation, what would your slash notation be? I hope you got it. You just count the ones. So we have 24 ones to this point, and then 2 more. So that's 24, 25, 26. That's a slash 26. Okay, now we subnetted all of these out here, and we know that we, have 4 subnets that we got from this, but there's a faster way to answer that second part of that question about how many networks. We just use our old formula from the last video for number of networks. Now, in that last video, I might have some practice videos in there in between where I use the n 2 to the power of n, but in the original video, I put a question mark. 2 to the power of what? Because I wanted to kind of make you think. We're looking for this number here. Sometimes students miss that part. So by putting a question mark there, then that's the number we're looking for. But I usually use an n there when I'm doing a calculation for number of networks, because that reminds me that I'm looking for network bits. So how many networks do we have? 2 to the power of n equals number of networks. Well, how many ones did we end up with in our interesting octet? We ended up with 2 ones. If we look at our powers of 2 table, 2 to the power of 2 equals 4. So the formula tells us how many networks we will have. We didn't even need to subnet this all out to know how many networks we have, but it's actually pretty fast if you're not talking like I am while you're doing it. So it's really quick to lay out your networks, but you can do it with the formula, which is even quicker. So overall, this question wasn't this difficult. It is one of the basic things you need to know to move forward with your subnetting skills. Keep watching the subnetting series, and we'll get into some of those really complex subnetting questions that you're going to run into, and we'll go through some of them and solve them. Sometimes you just need to see somebody else solving a question, and then something clicks in your mind and you go, oh, that's how you get the answer to that. If you have a question that you don't understand, feel free to put it in the comments and I'll try to answer it for you. I love doing that. I love answering subnetting problems. It's great. Not test questions though. Don't give me your test questions or your instructors. Maybe I won't give you the answers, but I'll give you hints on how to do it. I'm not into giving people answers. I want you to learn. Thanks for watching. I hope you got some good information out of this video. In the next video, I'm going to do VLSM. We're going to use this exact same formula, and you'll see how VLSM works using this formula. I hope to see you in the next video, and I'm really glad you were here with me. All right, bye-bye.